Welcome to our video. I'm really sorry I can't be here with you today. I'm doing a gender dialogue, which is important work to do here at GFS. So welcome to class. I'm happy I can still be with you virtually. I made this video last night, so hopefully it'll help. We're gonna do some practice problems. So the first one is that Maeve decides to skydive. Her mass is 65 kilograms. 4 seconds after jumping, the skydiver encounters air resistance of 600 newtons. Sketch it. Okay, you try on your own first. So go ahead and pause the video. Welcome back from the video. So hopefully you drew me. Here I am smiling because I'm skydiving. It's very exciting. And the force is acting on me while my weight is going down. That's the force due to gravity. So that's my weight. And there's air resistance pushing back up. So that air resistance. And my weight, we know, is mass times acceleration due to gravity. So I've got my 65.0 kilograms times 9.8 meters per second squared. And my force, that's air resistance, is 600 newtons. That was given to me. Excellent. All right. So part B, what is the net force in the skydiver 4 seconds after jumping? Net force. Okay, again, try this on your own. You try. Pause the video. Welcome back from the video. Net force. Well, it's basically the sum of our forces, right? The net is the sum of everything that's going on. So the only thing we have to remember is that the air resistance is in one direction. So net force equals air resistance. And the weight is in the opposite direction, so I'm gonna make it negative. So, okay, opposite direction, so we'll call weight negative and we'll call air resistance positive. Fantastic. So I have that F net is equal to 600 newtons, and then I'm going to subtract my weight, which was 65 kilograms, times that 9.8. And so this gives me 600 newtons, and then I'm subtracting, it ends up being 637 newtons, that's 65 times 9.8. So hopefully, easy arithmetic here, we just get negative 37 newtons. So really, the way that we're thinking about this is it's 37 newtons downward. So my net force is downward, okay? So part C is saying, what will the skydiver's acceleration be, including magnitude and direction, 4 seconds after jumping? Try this on your own, and remember that acceleration is caused by net force. Okay, pause the video. And we're back. So if you remembered that acceleration is caused by net force, and you remembered you were studying Newton's second law, then we've got F equals ma, and we rewrite it to get acceleration. So we rewrite this as A equals F over m. And we're talking about the net force and the total mass of the situation. So I've got 37 newtons downward is that net force, and I've got my mass, what was my mass again? Oh, 65 kilograms. 65 kilograms. Easy enough. I divide those two and I'm left with, let's see here, 7 divided by 65, and I get 0.569 meters per second squared. Downward. You need to make sure that you're saying downward. 0.569 is the magnitude, downward is the direction. Part D, what would be the air resistance in order for Maeve to be at her terminal velocity? Think. And then go ahead and talk with your partner, just like we do all the time, all right? Turn to your partner at your team, talk with your partner, and think about this. Pause that video. Thanks for discussing with your teammates. I'm so glad that you guys are still able to be such good students without me there. So terminal velocity really means that I'm not gaining speed anymore as I fall from the skydiving situation. So it means that Maeve will no longer gain speed. Therefore, what's really happening here is that I'm at a constant. I'm going at a constant speed. Constant This is otherwise known as equilibrium. I'm in equilibrium. This makes sense. Well, if I'm in equilibrium, then the net of the forces is 0 newtons, folks. And so if my weight going downwards is 637 newtons, we got that earlier, right? 65 times 9.8 is 637. So then the force of the air resistance needs to be 637 upwards. Excellent. So proud of you guys. Great job. Okay, moving on. Go ahead and pause the video and discuss as a class and make sure that you all can understand everything. Do like a stand-up, stand-up, pair up, or something like that. All right. So welcome back. We're on to question number 2. All right, I want you to read the question and I want you to try it on your own. So pause that video again. Welcome back to the video. So I hope that you drew like a bunch of people over here, and they're on a cliff, and I've got a rock, and I've got a pulley, and maybe some of you didn't draw this because some of you may not have actually known what this looks like in Mulan, but this is what it looks like. And there's the horse. And we got Mulan, and actually she's got the dude with her too. I forget his name, the handsome dude in the story. Anyway. Here's the whole setup, and we've got Mulan and the horse's weight going downward, so that's 90.8 kilograms times 9.8. Again, that's mass times the acceleration due to gravity, and that gives us weight of Mulan. And then we've got the people, there's weight going downwards there, and that's that 226 kilograms, their mass times the acceleration due to gravity, which is 9.8. And it doesn't really matter what that is, but we know that it's exactly the same as the normal force pushing back up on them. Okay, so they themselves, you know, without this string attached to them and without the horse, they're like in equilibrium, right? But then Mulan and the string and the horse is this extra mass and extra weight going down. So now try letter A, net force due to gravity. Pause the video. Welcome back to the video. So F net in this situation, remember that the net force is a thing that's like causing or making the acceleration happen. So we realized that the people would be totally fine on their own, the group of people, if it weren't for Mulan hanging over the edge. And so she's causing the acceleration. And so it's the horse and Mulan. They're causing that acceleration. And so their weight is that net force. Especially since we're disregarding friction, right, everybody? We're disregarding friction, disregarding air resistance. So F net is simply 9.8, which is acceleration due to gravity times Mulan's mass, and the horse's mass, 90.8. And that's, again, acceleration due to gravity times mass, or mass times acceleration due to gravity. That is equal to our weight. That's the net force. It's 889.84 newtons downward. Good job, good job, good job. All right, finally, what is the acceleration of the system of both masses? And what acceleration does? Try this, try. Pause that video. Welcome back to the video. So we know that F equals ma, Newton's second law. This is our jam these days. We've got A is equal to F over m. So A is equal to F net over m total. It's helpful to think of F net and m total, especially in a system like this. It's got a lot of stuff going on. So F net, we said, was 889.89 from part A. And then if we look back up to our question, we've got 226 and 90.8. Those are our masses. So the total mass is both of those masses. 226 kilograms plus that 90.8 kilograms. Because it's the total mass of the whole system. Okay, so 889.84 newtons divided by, I add those together, 226 plus 90.8, and I get 316.8 kilograms. And now I divide 889 0.84 divided by 316.8. And I get 2.81 divided by 316 meters per second squared. Great job today. I am so happy that you did so well. If you could please hand up, stand up, pair up one more time to discuss, that's great. Thanks.